Question number 12, subdivision 1. Find integral x sin x dx using integration by parts by taking u equal to x and dv equal to sin x dx. Subdivision 2. Show that this method will be more complicated if the above selection of u and dv are interchanged. Here u is x, therefore du equal to dx, and integral dv equal to integral sin x dx, that is v equal to minus cos x. Now the formula is integral u dv equal to uv minus integral v du. This is integral u is x, dv is minus cos x dx, dv is sin x dx, x sin x dx equal to u is x, sin x is minus cos x, minus integral minus cos x is this plus cos x dx, that is equal to minus x cos x plus cos x is integral cos x is sin x plus c, right? This is part 1. Now look at this integral. Here we have integral x sin x dx equal to, after substituting u equal to x and dv equal to sin x dx, we get minus x cos x plus integral cos x. What about x? Here x power 0 dx, that is actually here x power 1. After substitution the power 1 is reduced to 0. If you reduce like this, then only you can proceed further. Now subdivision 2. Subdivision 2, it is you interchange u and dv and show that this method is more complicated. That is u equal to sin x, dv equal to x dx, then u equal to cos x dx, integral dv, that is v equal to integral x, that is x squared by 2. Formula integral u dv equal to uv minus integral v du, isn't it? Now this is equal to integral sin x, dv is x sin x dx equal to uv, u is sin x, v is x squared by 2 minus v x squared by 2, that is 1 by 2 x squared du cos x dx. Now compare with this. Here x power 1, the right hand side the power 1 is reduced to 0, that is why integral cos x. But here the power is 1. On the right hand side the power increases by 1. Now if you take this and you follow this method, then in the right hand side you will get the x cube sin x dx. That is, the power of x is going on increasing. It is never ending. Therefore, this, if you follow this problem will be more complicated. It will be more complicated. Therefore, here it is better you follow this method, u equal to x and dv equal to sin x dx. That's all. Question number 13, subdivision 1. Find integral x sin x dx. Same problem as that of the previous one, but the method is different. Using the derivative means d by dx of x cos x. Using this result, you try to find out integral x sin x dx. Now, what is d by dx of x cos x? UV method, you first cube cos x constant, x becomes 1 plus x into cos x becomes minus sin x. That is, when you differentiate x cos x, you get this one. This implies then the reverse process. If you integrate this, you must get the value x cos x. That is integral cos x minus x sin x dx equal to x cos x. Is it clear? Therefore, this is equal to, that is integral cos x dx minus integral x sin x dx equal to x cos x. Now that this implies integral cos x is sin x minus integral x sin x dx. You keep this as it is because we require this x cos x. Therefore, you take this other side, integral x sin x dx equal to x cos x, that is sin x minus x cos x. Is it clear? Over. Now come to subdivision 2. Prove that integral f of x into g dash of x dx equal to integral f of x into g dash of x dx equal to this one by using integration by parts. Now you take u equal to f of x, u equal to f of x, then du equal to f dash of x, dv equal to g dash of x dx. Therefore, integral dv equal to integral g dash of x dx, that is v equal to g of x. Now you apply the formula. That is, formula is integral u dv equal to uv minus integral v du. That is u f of x, v g dash of x dx equal to this one, equal to uv, u is f of x, v is g of x, minus integral v g of x du, du is f dash of x dx, which is the required result.